Add two numbers. Okay, everyone, today we are adding two numbers. They are represented by linked lists, and they simplify things a little bit because they give us the least significant numbers first. So that makes it easy for us because we don't need to find the end and then start working backwards. What they say is the digits are stored in reverse order. And so we can simply iterate until we find null, which makes things easier for us. So add the two numbers represented by these linked lists stored in reverse order, and return the sum as another linked list. You may assume the two numbers do not contain any leading zeros except the number 0 itself. Okay. So you can see 243, but this is actually 342. Okay, so first things first is we need to keep track of the total. First things first is we need to keep track of the total. At first, this is going to be 0. It's just a number we're going to be adding to. We'll add the values of the individual nodes to the total. So we do that with a while loop. So while L1, that's the first linked list, or L2, that's the second linked list. So while we have values, if L1 total gonna plus equal L1, but we need to say its value, not the node itself, but the value contained within the node. And we need to move towards the next node in the linked list. So we do that by saying L1, you are now L1.next. So you are the next node in the linked list. And we need to do the same thing with L2. So just change these to 2. And presto, we are now adding to the sum. But what if we add, let's see, two numbers together? Let's say we added 6, and what if this was 6 and this was 5? We add those together and we need to carry a number. What happens when we need to carry a number? Well, we're going to need to store that in a variable. But to determine if we need to carry it, we're going to need to see if the total, if we divide it by 10, when you need to carry a number. Within the while loop, each time we're going to need to determine if the number has exceeded 10. So each iteration will say if there is a number where the total percent 10, meaning the remainder, do we have a remainder? Is there a remainder? And if there is, then we're going to pass it to carry. So the remainder will be total divided by 10. So let's say we have 11 and we divide it by 10, and we get 1.1, well, that's not a whole number, so we're going to want to round down and just carry the 1. So math.floor, carry the 1. And so now we have something to carry. Okay. And what do we want to do with it? Well, on the next iteration, we're going to want to have the total be, we want the total to start out with the carry. So the total is 0, and then you add the values to it. But then on the next iteration, you will also have the carry as part of it. Okay. And so we need to create, so this is all well and good so far. We're adding the numbers to a total, and if we need to carry a 1, we are carrying the 1. It's carried over to the next iteration. But now we need to append these things to a new linked list. So first things first is we want to create our linked list. We're going to call this a dummy. So dummy is going to be our first node, and it's going to be a dummy node. It's not going to have anything. It's easier to append nodes to an existing node rather than create the first node within the while loop and then try to decide, have we already done that? Yes. And then on the next iteration, don't create a new node, but append. Instead, we will only append. So we create a dummy node, and when we return the linked list, when we return it, we're not going to be pointing towards the dummy node. We're going to be pointing towards dummy.next, which will be the first valid node. And so within the while loop, we need to be appending things. So we have dummy. Now we're going to say dummy.next is going to be a new list node, and it's going to be the number. So we're going to create a new node with the current digit and append it to our result. And then we're going to move forward. So move to the next position. So dummy.next. Advance the dummy pointer to the new node so the next digit can be appended after it. And at the end, we want to return dummy.next, which is the new linked list. But because we've been moving along, I don't think this is going to work. So let's try to make it work. Looks like it's timing out. And basically the reason is we need to store the head for the results. We need to store the head of the resulting array, which is just going to be dummy, like this. And so we're going to return results.next instead. So this will be the actual first node of our resulting array.